Welcome, everyone. We're so glad you joined us for today's adventure. My name is Air. Yes, the air. Your air. I am the invisible blanket of gases wrapped around the Earth, your home. You breathe me in every day. To play, work, sleep, dance, read, write, bloom, zoom, sing. To do everything.
I am space. You know, stars, planets, galaxies, supernovae, black holes. I am the big cosmic cheese, the vast, enormous, ever-expanding...
Oh, blow away, space.
You're amazing, no doubt, but today is all about my atmospheric awesomeness. Finally, I got my own show.
Wait. What do you mean, no space?
The planetarium has enough space shows, but you can hang around if you like.
Oh, great. Thanks, Air. What's so special about you?
Rainbows, auroras, meteors, and more. I'll show you what's up and where it's up in the
Let's enter the top layer of my atmosphere, the exosphere.
What? We are still in my area, space.
You are right.
Ha, told ya.
And you're wrong.
Say what?
It is mostly empty, but a tiny amount of my molecules are still here. You can't see them. That is the weirdest thing about me. I'm mostly invisible. People walk right through me all the time. My exosphere starts at 6,000 miles up, all the way down to 375 miles above the ground.
Still looks like space.
As we descend, we enter the thermosphere. It measures from 375 miles up, down to 53 miles above the surface.
Ooh, I see the International Space Station. Knew this was still me, space.
The thermosphere has more of my molecules, but it's still very thin. There is enough of me to bump into the ISS and slow it down just a little. So the ISS has small booster rockets to keep a steady orbit.
There's the Aurora Borealis, or Northern Lights.
That is me, being electrified. I will tell you more about that later. It is here in the thermosphere we find the Kármán line, where many people mark the border line between air and space. It is 62 miles, or 100 kilometers above the ground.
I am starting to see some of your molecules now, but barely.
We are in my mesosphere. This layer tops at 53 miles and goes down to 31 miles. This layer is where most meteors burn up.
Ooh, cool, space rocks. Get it? Space rocks?
Haha, more on meteors later. The stratosphere. From 31 miles up down to 6 miles. See these oxygen molecules? That is ozone. Ozone is the ultimate defense against harmful ultraviolet sun rays.
What about increasing carbon dioxide and other greenhouse gases, like methane and water vapor?
That is still a big concern. I am 78% nitrogen, 21% oxygen, and 1% other gases. But if greenhouse gases keep increasing, Earth people will need more renewable energies, like solar and wind power. My lower stratosphere is a smooth ride. About 6 miles up is where most jet airplanes fly. They cruise above my thickest part, which is the
Am I seeing mountains?
You are. Welcome to the troposphere, measuring from the surface around 6 miles up, give or take. The tallest mountain, Everest, reaches 5.5 miles high. Mount Denali in Alaska is almost 4 miles high. The troposphere can be crazy chaotic. All kinds of storms. But it can also be still and calm and cozy.
Sure, I bet people love a clear night to gaze up and see all of my stars. And maybe stay up for hours until another star rises, the sun.
Speaking of the sun, it is the ultimate cause of all my weather. Most people on Earth experience all kinds of weather with 4 seasons: spring, summer, fall, and winter. These seasons are not caused by distance, but by Earth's tilt, as it orbits the sun. When tipped toward the sun, people get longer days in warmer weather. And when Earth is tilted away, the sun is lower and weather gets cold.
So different places get heated unevenly.
You got it, Space. The sun also makes my beautiful blue skies.
Check out the blue sunset on Mars.
Come back down to Earth, dude. Remember, this show is up in the air on Earth, not up in space. Thought I clarified that in the intro.
Yeah, you did. Sorry, I get excited. So why is your sky blue? The sun is not blue.
Correct. The sun is white. It's a mixture of all spectral colors that behave differently because they all have different energy levels. My atmosphere is full of tiny gas molecules that scatter sunlight. Blue's shorter wavelengths can be seen at shorter distances.
Ooh, making your sky blue.
Exactly. When the sun is high in the sky, people look through about 60 miles of me, but never look at the sun when it's high up, because it's dangerous.
And you are red and orange on the horizon because...
They look through more of me, 40 times more. Over 2,000 miles of my oxygen and nitrogen molecules.
I get it. They look along the Earth's surface, so there is more of you, more air. That makes it safe for people to look at gorgeous sunrises and sunsets.
One of my best sky shows is my rainbow. Look at this colorful waterfall in Iceland. People see rainbows when sunlight passes through water droplets. Light bends or refracts into its spectral colors.
Every raindrop acts like a tiny prism.
And sometimes you can even see double rainbows. The second one is fainter and the colors are reversed.
Whoa, that's a full rainbow. All the way. Double rainbow.
You can even make a rainbow by washing your car or watering your yard.
What are those little rainbows? Do you hear dogs barking?
They are sun dogs. They flank the sun, one on each side, like dogs. They are caused by frozen water, ice acting like a prism. Ice crystals can reflect sunlight into vertical beams too, called sun pillars.
Ooh, very pretty.
Check out this sun halo, again, caused by ice crystals that reflect sunlight. And there are moon halos too.
Heavenly. My sun and you, air, we sure work well together.
We do. Clouds, weather, sky color, all of it is caused by the sun.
Yeah, what is up with your clouds? They always seem so different.
They are. Clouds are part of the water cycle. When the sun heats bodies of water, like lakes, rivers, and oceans, water evaporates into a gas, water vapor, which we cannot see.
Then all this water vapor rises into the atmosphere because warm air rises?
Right. As I rise, I expand and cool. I cannot hold much water vapor when I am cooler. So water condenses, collapses into tiny liquid droplets, or ice crystals, and starts making clouds people can see. Whether these clouds grow big enough to drop rain or snow depends on the balance between gravity pulling them down and me rising, keeping them aloft.
What are your thin, wispy clouds? Those are my favorite.
Ah, those are cirrus clouds. They form high in the troposphere and are composed mostly of ice crystals.
What are those boring clouds, all flat and grayish?
They are stratus clouds. They cover the sky like a flat sheet or blanket and often bring light mist or drizzle.
And the big puffy ones?
Cumulus clouds. When my rising clouds are more concentrated, that is when people see my cumulus clouds. And if my atmosphere gets unstable, look out! Cumulonimbus! Or thundercloud. They often grow vertically and make storms. And mammatus clouds. These are billowing bubble clouds that can sometimes form below thunderclouds. All this turbulent mixing can produce heavy rain and wild winds.
Like tornadoes and hurricanes?
Yes, these are my fiercest storms. Cyclones, too. They can be deadly, and I worry about them increasing across the globe.
I worry about lightning strikes. They are so scary.
Thunder and lightning are very startling. Lightning happens when billions of tiny water droplets and ice particles collide inside a thundercloud. This builds up lots of negative electrons that want to connect to positive charges on the ground. Tension builds. Look out! That massive zap of lightning can heat me up enormously. 5 times hotter than the surface of the sun.
What about thunder?
Thunder is a sound, a shock wave, caused by the intense heating of me. But thunder travels almost 1,000,000 times slower than lightning. If you see lightning and then hear thunder 5 seconds later, it means the lightning happened 1 mile away.
Okay, so if the thunder was 10 seconds later, the lightning was 2 miles away.
Ding, ding, ding. Exactly. Do you want to see lightning up close? Like, really close?
I think so.
Say hello to a plasma ball and a Tesla coil.
That's right. Lightning is plasma, the 4th state of matter.
Plasma occurs when high energy rips electrons away from my molecules, ionizing the gas. If the energy is strong enough, the gas glows. The electrode at the center drives the energy. This creates all the glowing streams of plasma, or miniature lightning. When you touch a plasma ball, you become part of its circuit. Humans are made mostly of water, which makes you very attractive to these tiny lightning bolts. The bolts are jagged because electricity searches for the path of least resistance. All my gases in the sky and the gases inside the plasma ball are uneven or non-uniform.
So lightning zigs and zags, finding the fastest way.
You got it, Space Cadet.
Hey.
Understanding lightning sure can be shocking.
Funny air, funny. You know, Jupiter has lightning too, and Saturn, and Uranus.
Yes, space. Hey, throw me one of your space rocks. A tiny one.
Whoa! What happened to my teeny little rock?
It got vaporized. These space rocks are called meteors. People love to call them falling or shooting stars. They burn up very high, about 50 miles up in my mesosphere.
Oh, awesome. But why such a bright light for a tiny rock? They must fall at incredibly fast speeds.
They do, up to 40 miles per
Hour?
second. The meteor burning up is only 5% of the light people see.
Well, what's the other 95%?
Me! All my atoms get heated to extreme temperatures, making hot, glowing plasma.
Bigger rocks must produce even more plasma and are even brighter.
If the rock is as big as a beach ball, 3 feet across, they are called fireballs, or bolides. A huge space rock, 60 feet across, fell over Russia in 2013. It got so hot, it exploded. Only a tiny portion hit the Earth as meteorites, but most of it just vaporized.
I bet it produced a lot of plasma.
Oh yeah, it was brighter than the sun.
Did you know the sun is plasma? As are all the stars in the entire universe.
Trying to steal my show again, Space?
Well, maybe a little, you know me.
Yeah, you're all right, Space. I have one more sky sight to show everyone.
Breathtaking.
It is the Aurora from the South Pole. It is called Southern Lights or the Aurora Australis.
So, from the north, is it the Northern Lights?
Yes, or the Aurora Borealis. Look how it dances and pulses. People marvel at the various patterns and shapes. This electric light happens around the Kármán line, which is
62 miles high, the unofficial border between you and me, air and space.
the Aurora's glowing ribbons are the result of amazing connections between the Earth and Sun.
The sun is constantly powerful.
And sometimes it gets crazy powerful. Check out these huge sunbursts captured by NASA telescopes.
What's that circle blocking the center of the sun?
A coronagraph. It hides the sun's bright light to reveal coronal mass ejections, or CMEs. These massive solar eruptions cause my aurora. Billions of tons of electrons and protons are released at over 1 million miles an hour. It can take 1 to 3 days to reach Earth. Then...
Look out!
Right, sounds scary. But Earth is a giant magnet. It produces an invisible force field called the magnetosphere.
When this sun blast hits the magnetic field, most particles are deflected.
The sun particles get trapped along these field lines and then collide with my upper atmosphere to create the lovely aurora.
The aurora is like a giant glowing neon sign.
My different gases produce different colors. Look at all these stunning pictures of the aurora. Green is the most common. That is my oxygen. Though oxygen can make red too, after an intense solar storm. Nitrogen molecules create purple, pink, and even blue sometimes. The exact shades depend on how high the sky the aurora is dancing.
Astronauts on the International Space Station can see auroras too, from above.
Sure, and if you're even further away, the lights look like glowing rings around Earth's poles.
So that means the best places to see them are far north or far south.
You need dark skies, clear weather, and a little patience, and a little luck to see this magnificent sight. Long before scientists understood the aurora, people told wondrous stories to explain the lights. The Norse believed the lights were reflections from the armor of Valkyries, warrior maidens riding across the sky. In parts of Finland, the aurora was caused by a magical fox. Inuit traditions say the lights were spirits playing games in the sky.
Across many cultures, the aurora felt enchanting.
And still does today. Even though we know the physics, the aurora still feels magical.
You know, Air, the aurora reminds me of how the sun and earth are so connected. Together, we create blue skies, red sunsets, rainbows, meteors, and so much more.
We do, Space. We do. It is hard for me to shine without so many interactions with you, Space.
We may be different, but together, we make air and space a fascinating place for all the Earth people to explore.
Exactly. When people look up, they can see all kinds of breathtaking skies.
And right through invisible you, and out into glorious me, space!
Okay, Space. Just had to get the last word, didn't you?
Well, I am so enormously great.
And sometimes enormously exasperating.
Wait, what was that?
Oh, nothing.
Nothing. I'm everything. Stars, planets, galaxies, black holes. I could go on. Think I will. Space is the place. There could even be aliens out there. You know, life beyond the Earth, maybe on Mars, or Europa, a moon of Jupiter, or
Oh
Enceladus.
my. Time for some of my super speed wind again.
Oh no, wait, where's my voice going?
It's up in the air.